Hi, my name is Alex Fleischman, and welcome to the video overview for the refraction demonstration. Alright, let's start this demonstration off. This demonstration will show students how waves of light experience refraction when an object moves through different mediums. Students will observe refraction and reflection by placing a ruler in water. The purpose of this demonstration is to introduce students to refraction, indices of refraction, angle of incidence, angles of reflection, and the critical angle. Okay, so how are we going to go through this demonstration? First, fill the glass with water and place it on a flat surface. Slowly submerge the ruler at a slight angle to the normal line. Observe how the image is displaced when the ruler is viewed from the side. Well, this is due to a phenomenon called refraction, which describes the bending of a wave of light as it enters a new medium. The image viewed from above is not displaced because the angle of reflection of light is equal to the angle of incidence of light, so the image is not displaced. There exists an imaginary normal line perpendicular to the surface of the medium. The light rays will either bend toward or away from the normal line. This bending is based on the index of refraction, which is an intrinsic property of all mediums. The index of refraction is a numerical value which is calculated by dividing the speed of light in a vacuum by the speed of light through the medium. There is an angle called the critical angle, such that a wave of light that enters a medium at an angle equal to or greater than the critical angle will not be refracted, and will only be reflected. Alright, let's go through a simple question. The index of refraction of air is about 1, and that of water is 1.33. Using what we know about indices of refraction, does light travel faster in water or air? Light travels faster in air. We know that the index of refraction, n, is equal to the speed of light in a vacuum, which is a constant, divided by the speed of light in the medium. Since the index of refraction is inversely proportional to the speed of light in the medium, we can conclude that the medium with the lowest index of refraction allows light to travel through it without the greatest speed. Air has the lower index of refraction, so light travels faster in air than it does in water. Alright, observing the ruler and the way it bends in the water, and using what we know about the indices of refraction of the mediums, what can you infer about how light bends relative to the normal line? We observed that as the ruler entered the water, it bent toward the normal line. If we look at it such that we start out of the water and move into the air, the ruler bends away from the normal line. Therefore, when going from a lower to a higher index of refraction, the light bends toward the normal line. When going from a higher to a lower index of refraction, light bends away from the normal line.